Welcome to this video on distribution analysis. So let's get started with the necessary libraries. We are going to use employees attrition data in which every row belongs to an employee and we have details about each employee like their age and whether they are still staying in the organization or not. If they are staying in the organization, value will be 0, attrition value will be 0. If they have left the organization, the attrition value will be 1. And especially this dataset can be used for classification in which attrition column becomes your target variable. We also have various other details like their business travel, daily rate, department, and numerous other details about each and every employee. We have it. So close to 1400 employee details we have in this data frame. So what we are going to do in this is we are going to focus on one of the numerical column, which is monthly income. So I'm going to use box plot to understand distribution of monthly income. So you can see here the median line is approximately around 5,000. So 50% of the employees earn less than 5,000 and 75% of the employees earn less than approximately 8,500 or so. Okay, this is the third quartile that we are seeing here, and we can clearly see that there are dots above upper whiskers. So there are some outliers. There are employees whose salary is way higher than 17,500 or so. So we get to see the distribution of a numerical KPI, which is monthly income in this particular case. So now we're going to just deep dive and understand how this numerical variable monthly income is affected by various categorical columns. So we are going to use box plot, but not just one box plot for the entire column. Instead, we are going to divide box plot based upon different categorical columns. For example, here I am going to generate two box plot, one for female and one for male, using gender column. So I'm taking help of a categorical column to understand its influence on the numerical KPI which I'm looking for, which is monthly income. So I want to know how gender is influencing my monthly income in terms of distribution. So here if you check out, the box plot is almost same, right? Except for a very minor change in the third quartile. So the third quartile for female is slightly higher, as well as the upper whisker is slightly higher for female, but overall the distribution of male and female looks almost same. So we can conclude that there is gender equality in this particular organization at least. So people are not judged based on their gender. So gender is not kind of influencing monthly income. So what else can we just look at by department? So we can see department, so to a certain extent it is influencing. So we can just see that employees under sales department are earning slightly higher compared to the other department. So this IQR, the box height or the portion of this box is slightly higher compared to research and development and human resources department. So there is a slight influence of department when it comes to monthly income. So here let's take how job role is influencing monthly income. So here we can clearly see a huge difference in monthly income when it comes to job role. So here if you see this box plot for manager, the portion of your IQR is way higher, and generally managers are paid well in this organization at least. Whereas you check out a research scientist, their pay scale is on the lower side, whereas sales representative is also on the lower side. So one thing that you can comment on this particular box plot is the IQR is very small and the value is approximately, let's say, close to 2500 or so approximately. So I can just tell that for any sales representative, approximate salary is around 2500 because their IQR is very small, and only for few employees the salary is quite high. That too not very high, but compared to this group, their salaries are quite high, and there are few sales representatives whose salary is very low. So when IQR is very small, we can just very particularly tell that most of the people in that particular group have similar monthly income. Whereas here, if you see, the IQR of a research director is varying, so you can just pinpoint someone and say this is your salary. Whereas for sales representative, I can approximately mention that their salary will be around 2500. So this is the kind of inferences that you can make on top of box plots. Of course, you can comment on what type of distribution it is, whether it is left skewed, right skewed, normal distribution or so. But then we can use histograms for that instead of box plot. So in box plot, primarily we'll be looking at how the distribution is looking for different categorical variables on the selected numerical KPI, and then are there any outliers. For example, here I can see for sales representative clearly there are outliers, and research scientists there are few people whose salary is way higher than their counterparts. So instead of looking at outliers on a single box plot by taking the entire column, it's always good to look at outliers by just dividing the box plot with various categories by taking help of a categorical column. So now what I'm going to do is identify those sales representatives who are kind of outliers. So we are going to detect outliers. How are we going to do? Using the concept of IQR, and then we'll be calculating lower whisker and upper whisker values. So what I'm doing is I'm filtering only for sales representative, this particular group alone. I'm filtering in the job role column, and then calculating Q1 first quartile using quantile function. So you have to give 0.25 for first quartile, zero point 0.5 for second quartile, and 0.75 for third quartile. So you have to give 0.25 for first quartile, zero point 0.5 for second quartile, and 0.75 for third quartile. So Q3 can be calculated using dot quantile 0.75. Now IQR is nothing but Q3 minus Q1, and we can calculate lower whisker, which is nothing but Q1 minus 1.5 times IQR, and upper whisker is Q3 plus 1.5 times IQR. So this is a standard calculation. Softwares or visualization tools might use a slightly varied calculation, so it depends on the packages, but this is one of the standard calculation for calculating the lower whisker and upper whisker. So the lower whisker value is 1307. So any sales representative monthly income, if it is less than 1307, we can consider that as an outlier. Likewise, any sales representative whose value monthly income value is higher than 3821, we can consider them as an outlier. So based on the statistical analysis that we have done. So how do you just pinpoint those outliers? So you filter again sales reps data frame in which monthly income is less than lower whisker, or monthly income is above upper whisker. So you will get to know the rows in which you have outliers for sales representative. So likewise, you have to do outlier analysis for individual groups separately. Then you can decide what you want to do with those monthly incomes. You want to reduce or increase, or you want to impute missing value and then treat those missing values. So based on your analysis, you can decide which outlier treatment might be appropriate. So you can also get those row numbers. So you can just ask for the index and then convert it into a list. So what we have done, we have used boxplot to understand the distribution of a numerical KPI, and also we did outlier analysis. So now let's look at what kind of distribution it is using histogram. So here I'm using dot plot dot hist on top of monthly income column. So you can see that it's a kind of right skewed distribution because you have a long tail on the right hand side. So what I generally do is instead of plotting the histogram to identify the distribution, I plot the density function. So you can do that using .kde. So it just gives you an approximate distribution for the numerical variable that you're looking at. So here you can clearly see that there is a long right tail. So this is a right skewed distribution. So let's calculate the skewness using dot skew function. So here the skewness is 1.36. So we can clearly see that this distribution is skewed. So there are multiple ways in which we can reduce the skewness in this particular column. You can take a lot of transformations. For example, here I've taken a log transformation, converting all the values into log form using np.log, and then looking at the distribution. So you can see the skewness has reduced a little bit and it is moving close to a normal distribution compared to what we have here, right? So now if you calculate the skewness, you can see the skewness has reduced to 0.28. So this is one of the technique to reduce the skewness. You can try out inverse transformation or square root transformation and see in which of those transformation your skewness is coming down, because for many machine learning algorithms you might have to reduce the skewness in your input variables. So this transformations can be quite helpful.